So hello everybody, it is Tuesday the March 8th, and here's our do now. The diagram in here shows a model of an atom that has 4 different symbols on it. Each symbol represents a different role for the particle in the atom. So in here we have X's and Y's and our nucleus. Oh yeah, that's right, protons and neutrons, you can pick whichever. W is an electron and Z is an electron. But they're separated out. Oh, but in the model above, which particle determines the reactivity of this atom? Well, W doesn't, but Z does, because remember, we're supposed to have 8 electrons, and we have 6 here. So we remembered that from when we worked on our Bohr models. So today I will learn to draw and label a Bohr model of the atom. I can define valence electrons, determine how many shells an element model needs, and I can draw protons and neutrons onto a Bohr model, and I can rate an atom's reactivity. So drawing a Bohr model, what's a Bohr? Well, Niels Bohr. He was the quantum physicist and who discovered the understanding of atomic structure, and he received a Nobel Peace Prize. So what I want to make sure we're talking about is that we have, we're talking about valence electrons. That is the one in the outermost shell. So if we look at this, we can see that there is an outermost shell here. And in our outermost shell, this one right here, we got 1, 2, 3, 4, 5, 6, 7, 8. Yep, so that one doesn't have any. So each shell has a limited capacity. Like seats in an auditorium, first shell has 2, so that's this yellow ring. Second shell has 8, and the blue shell has 18. But right now, because we're in 8th grade, we're going to say it has 8. So we're going to kind of drop the 1. You must completely fill a shell, so you can't seat hop. You got to fill the shells before you move on. And this is the Bohr model, and this is how they're arranged. Each ring, all of the protons and neutrons are in the nucleus. The first ring holds 2, the second ring holds 8, the third ring can hold up to 18, but we're only going to worry about 8, and then the fourth ring can hold up to, well, that's pretty complicated, and you'll get into that in chemistry in high school. So our next thing is to talk, why do they matter? So this is slide 10 in your notebook. You're going to want to pause here, open another tab, and check out and fill these in. So when we have valence electron of 8, and that's family group 8, if you look at your periodic table, that is our friend, the noble gases. And then for reactivity, the families, and that's going down, the groups going down, groups 2, 13, 14, 15, and 16. And why those? Because they're special. The ones in the center have a whole different set of rules, but we're only concentrating on these columns. These are what we would just call reactive, like beryllium and carbon. And something that's highly reactive is lithium or fluorine, and those are in rows 1 or 17. And if you remember from the video, we talked about and showed you that we had lithium, we dropped it in water, and it was highly reactive. It fizzed and spittered and went from being a bar shape to rolling into a ball to evaporating. So we're going to draw an oxygen. Here's the steps every time. You're going to write out 8-man, draw the nucleus with the number of protons and neutrons, determine the period, the number of shells, draw the shells. So if we're in period 1, we have 1 shell. If we're in period 2, we have 2. Determine the number of electrons, draw them. Remember, 2, 8, 8, and then check your work. So this is what oxygen looks like. So we have 2 and then 6 on the outside. So if we're doing carbon, we repeat the same procedure. And this is what carbon looks like. We have 2 and then we have 1, 2, 3, 4. Okay, 6 protons, 6 nucleus. And I find this P equals 6, N equals 6 to be really easy to use. It's much easy for you. All right, so let's try neon. This is what neon looks like, 2, and then we have 2, 4, 6, 8. So there we go, 10. And then there's aluminum. Here's aluminum. So we're concerned that we have 13 electrons. So 2, 4, 6, 8, 10, 11, 12, 13. Because we remember, protons and electrons are the same. So we're going to start this worksheet today, and you're going to kind of tell us what the number of protons, what its identity is from the periodic table, how many valence electrons you think it's going to have. So you're going to have to do a little math, and then its group number. If you know what its identity is. So if you look up P7, you'll be able to find out the group. That's the up and down columns. And then is it highly reactive? So you're going to have to refer back to slide 10 in your notebook. And drawing these slides are slides 11, 12, and 13 in your notebook. Okay, and as the exit ticket, we had you draw a model of fluorine. All right, so that's what we're doing today. Tomorrow we're going to continue some more Bohr model work, and we'll talk some more later. So have a great afternoon.